In today's video, we are going to talk about the ultra rare Worcester piebird. These were common in the 1920s and 1930s, probably even into the 1940s. They are an ornamental culinary item, and they were specifically meant to be baked into a pie, such as an apple pie or a cherry pie. You would place them in the middle so the top portion is sticking out, and then it is served as more or less just for decoration. So what makes this unique is it has a black uranium oxide glaze. And I say black in quotations because it is a uranium oxide glaze. It probably started out as red when this was being initially made, but the glaze was mixed either with an iron oxide or some other type of pigment that gave it the rich black color. Typical of the glazes of the day, this is a Bauer. They are radioactive. They mainly put out betas and some alphas with very few gammas. You can detect gammas, which I'm going to show you here in a minute, but that is a typical orange uranium oxide glaze that we see. So, but with the piebird, as you can see, it's a really nice, deep, rich black color. So let's see, how radioactive is this? What I've got here to do the first test is a Ludlum Model 3 with the 44-38 pickle probe. And I've got the beta shield closed, so let's see. Which means it should only pick up gammas. Maybe a little tiny bit over background. If you did a time count with this, you might pick up a few extra clicks per minute compared to background. Not too much. So let's open up so it can accept some betas. And we definitely have a little bit more activity right there. Or I should say registered activity. All right, so let's see how much gamma radiation this puts out utilizing the CT007M gamma scintillation detector with a 1.18 by 1.18 square cesium iodide crystal. Right now the background in the shop is running about 36 to 3200 counts per minute. I do have a couple of sources here that are radium based where it's kind of giving a little bit of a higher level, but regardless, let's see what we got. Okay, so we do have an uptick for that, and the cesium iodide crystal might be registering a few betas out of this, but mostly what you're seeing is a uptick in gammas. There we go. If we put it on the bottom of the crystal, we do have a little bit higher of a register. And I did gamma spectroscopy on this several years back, and it is indeed uranium oxide. Okay, that is it for today's video. Probably coming up the next day or two, or maybe even this evening, we will discuss this. This is the famous 1B22 electron tube, which has a very strong radium emitter in the middle for ionization enhancement. And we can see this one definitely is pretty strong. So be on the lookout for this video. That one's going to be pretty interesting. And I got a few other tubes I'm going to profile on that one as well. All right, if you got any questions, specifically even about the detectors that I've got here, feel free to ask. As you know, I made a video here about the DG2 Detectron a little while back. So if you haven't seen it, scroll back and you can talk about this one. I am going to make another video about this one showing how I converted it to use normal batteries of today. This one here is just a classic Ludlum Model 3 with the 44-38 pickle probe. It's kind of my go-to detector for this type of stuff for doing things out in the field. And as you know, I just made the video about the two CT007 units. All right. That's it for today. I'll see you on the next one.